Hi. What we're going to look at is division of polynomials today, and we have three different types that you're going to be responsible to know how to do. The first one deals with, and if you look here, it deals with dividing by a monomial. It's probably the simplest. We'll go through a couple of examples. It's not too difficult. And then we're going to look at what if we have a binomial, and mainly we're going to stick with dividing by binomials rather than trinomials. But one of these methods can be used for even like dividing by a trinomial, but we're going to keep it pretty simple and just use binomials. But to start with, we're going to take this polynomial and we're going to divide it by this monomial, this 3x. So what I'll do is I'm going to go ahead and copy it because I believe this is how Pearson will present the problem to you, is it will look something like this. All right. So what you'll do is when you have just a single term here, you will put this term under each one individually, under each term in the numerator individually, and reduce those individually. So here is an example. We'll take our first term, and I will write this out. I feel like the more you do in your head, the more you're going to miss. So we have x to the fourth over this plus 15x cubed over 3x, and I'm up that 4, going back to that 4 is not good. And then we're going to put the last term above our denominator. So you just kind of split the fraction up, kind of working backwards. Usually when we add or subtract fractions, we have a common denominator and we get them under 1. So we just sort of did a reverse move here in adding fractions or subtracting fractions. Okay, next step is to reduce these individually. Well, again, we've got 1 and a 3 here, so we have a 1/3. But when the bases are the same, going back to our rules, we in division, we subtract exponents. So you can write this a couple of different ways. You can write the 1/3 out front. X 4 minus 1 is 3. Don't forget that 1 is there. That's a common thing to forget. You could write it like that. Another way to write that would be you have x cubed over 3. Either one will work. They're both correct. You can move the 1/3 in front, or you can just put that over the 3. All righty. Going to the next one, we have a plus. Reducing these, the 15 and the 3 reduce to a 5. And then we take 3 minus 1, x squared in the numerator. Okay, and now we do our last term. We have a subtract. 6 over 3 reduces down to a 2. And 2 minus 1 is 1. There's your solution. Now, this solution is called a quotient. So the solution in division is a quotient. So if they say, find the quotient, they want you to divide. It's the answer in division. So this is a simplified form of this right here. All righty, let's go ahead and look at one more example of this type, and then we'll go to dividing by more than just a single term. Looking at this example here, I'll go ahead and I'm going to rewrite it. We have 10a squared b to the 4th. I'll just write those. 2a cubed b squared plus 6a squared b divided by negative 2a squared b. You're going to have to kind of pay attention to that negative there when you do divide these out. I'll rewrite them as individual terms. We have 10a squared b to the 4th over negative 2a squared b. I have that subtract there. 2a cubed b squared over negative 2a squared b plus 6a squared b. Make sure it's showing up on my document camera over negative 2a squared b. So until you get pretty comfortable with this, you may want to rewrite it again so that you don't make as many mistakes, little mistakes. So now we're going to, now that we've distributed, kind of think of it as distributing this underneath each of these, we're going to reduce each of these three terms individually using our rules for exponents and division. Again, 10 over a negative 2 is a negative 5. So this one, I'm just going to kind of set over here. Negative 5. Now we have a squared over a squared. Well, let's review our rules to find the quotient or to divide. You take, and when the bases are the same, you subtract the exponents. Well, 2 minus 2 is 0. Anything to the 0 power is 1. So in other words, these two cancel each other out. It would be like taking a negative 5 times 1, which is still a negative 5. So it has no effect on the answer. Now here, going to the, so those cancel. We've got b, 4 minus 1 is 3. Alrighty. So there's our first term. The a squareds cancel. They're equal to a 1. And you don't need to include that 1. Negative 5 times 1 is still just a negative 5. And then b cubed. Let's go to our next term. Well, the next term, you have a negative and a negative. And in division, a negative over a negative is a positive. So we know when we have the two negatives here, our answer will be positive. And then we have 2 over 2. So we took care of the negatives just now and got a positive. 2 over 2 is 1. All right, so those cancel. A cubed, a squared, 3 minus 2 is 1, a to the first. 2 minus 1 for the b's, subtracting their exponents, b to the first. So that is the second term. These canceled. Negative 2 over negative 2 is a positive 1. And then you subtract the exponents. Let's reduce the next one. Positive over a negative, we have a negative. So we'll use a subtraction there. If you use plus a negative, it's still right. If you want to keep that positive and just make this last term a negative, you can. So these give you the subtraction. 6 over 2 is 3. The a squareds cancel. They're 1. B, those cancel. And there's your answer. All you have is the minus 3. Or plus a negative 3. If you want to write it like that, you're more than welcome to. Pearson should accept that. So here's the quotient for these two here. All righty. Now let's go ahead and we're going to go to what happens if we have a binomial rather than a monomial. This right here determines which method you're going to use. It's that denominator. And there are some methods that are easier. This last one isn't too bad. And depending upon this, we might either be able to use long division or what we're going to talk about, synthetic division. All right, but in both cases, here we have x plus 3 divided by this. Well, I'm going to go ahead and write it. Let's see, I'm going to put it down so I can reach. We have 4x to the 4th plus 2x squared minus 5 divided by x plus 3. Well, going back to your elementary years with long division, we know that in long division, I'm going to write a real quick one right here, 6 over 2. If we want to write it long division, this number goes outside, the top number goes in the box. And then you ask yourself, okay, what times 2 gives you the number in the box? Or close to it without going over. So we're going to set this up just like this. So you're going to see some similarities between this process and this process. So we've got x plus 3. and your top number goes in the box. But we have to kind of look at this right here. How do we put this in the box? We can't just write it like this. You have to kind of pay attention to these exponents here. So some things to remember. Always write the polynomial in descending order. Okay, now what does that mean, descending order? It means you always start, when you're rewriting this top polynomial inside the box, you always start with the highest power first and then go to the next power. But what if you're missing the next power? If any terms are missing, write them in using a 0 as the coefficient. So what they're saying here is that we have an x to the fourth, we have to have an x cubed, an x squared, an x to the first, and then the constant. All of those terms from 4 on down has to appear here inside the box. So if they don't appear here, you're going to have to put them in here as 0 x cubes. So we're going to take our terms. Okay, we have a 4, we have to have a 3, but the 3 doesn't occur here. So we go plus 0x cubed, 0x cubed. We do have an x squared. Okay. We do not have an x. Always use plus if you're missing it. So we have a 4, 3, 2, 1, and then our constant minus 5. And the reason we're doing this is that so things line up once we start our processes. So if you're missing a term as you go down, make sure you add it. And that's a really common thing to forget. And we're actually not going to do the division right now. We're just learning how to set these up. So the bottom number comes out on the top. This goes inside, but if you're missing a certain term, you have to add it in as a 0x cubed. And then if you forget, you're going to see as you go through the process that things aren't lining up, and you'll have to erase it and go back and say, oh, I forgot to add. It's so easy to forget to add the missing terms. All right, so let's go ahead and we're going to look at some here. We're going to practice this whole idea. I'm going to scoot this down. All right, so looking here, we're going to find the quotient. We're going to take this divided by this. So we'll be taking x plus 3. This process is called long division, divided by x squared plus 5x plus 6. Now, I had a 2 and a 1. So I had all of the terms from the highest power on down, so I didn't have to add any 0x. If I were missing that 5x, I would had to have put in a 0x right there to make sure I've got all the terms present from the highest power on down. Okay, now what do we do? Well, what we're going to do is we're going to review looking at something like this, going back to just numbers to kind of give you an idea of the process we're going to be using with these algebra expressions. Okay, now going back, you say, okay, what times 2 gives me 3? And again, I'm not looking at the 5 and the 7. I'm just looking at the first term. 2, what times 2 gives me close to 3 without going over? Go 1. Then you multiply. 1 times 2 is 2, and you subtract. And we're going to be using that exact same process over here. All right. Now then you bring down the 5. We're going to be doing that over here. So now you ask yourself, what times 2 gets me close to 15? Well, this is going to be a 7. Then you take 7 times 2 is 14, and you subtract or change the sign and add. And then you bring down the next term. Okay. What times 2? You get 8 times 2 gives you 16, so 1 left, and then you have a remainder. What do you do with the remainder? You put 1 over 2, and we'll be doing that with this process. So we're going to be multiplying, changing the signs, okay? Add them together, bring down the next term. What you looking at this, then we ask ourselves, what times 2 gives you this? Change the signs, subtract, bring down the next. We're going to be doing the exact same thing over here. It just looks more confusing because of the algebra. All righty, so let's go ahead and get started using this exact same process. And we're even going to do pretty much the same thing if we have a remainder. But in this case, we won't have a remainder on this first one. Okay, what you'll do here is that you ask yourself, what times x gives you x squared? So to start out with, that is a little bit different than this in that we ignore the 3. So just like, what times 2 gives you 3, what times x gives you x squared? So we just set this up using the first term. Well, x times x gives you x squared. They have to match. Okay. Then you take x times the 3. Okay. So you set it up using the first term only. X times x gives you x squared, but then you do have to. See how things line up? That's why we have to add those 0 x's. Then here we subtract, we change the sign and add. We're going to change the signs and add them together. That always drops out or you've done something wrong. 5x minus 3x is 2x. Then you bring down the next one. Now, for the next term, you ask yourself, what could I multiply the x by to get 2x? Well, that would be a positive 2. So you'll always have a plus or minus up here, separating your terms. 2 times x is 2x. Good, it matches. But then 2 times 3 is 6. Sometimes that won't match. If you have a remainder, it won't match. You change the signs. It's a subtraction. So you change the signs and add. You get 0. That drops out and that drops out. So there's no remainder. Now, what does this mean here? As a way of check, that when you multiply these together, if you were to multiply these together, you're going to get this right here. So if I take this times this, I get this. So it's a way of breaking things apart, which we'll be doing in the next chapter. It's called factoring. It's kind of like fracturing. You're breaking things apart. So these two multiplied together give you this. So it's a way of checking if you wanted to, unless you have a remainder, and then that's really not that much fun to check it. Okay, let's practice this long division process again. And again, it's just the same process again and again. Tedious, many places to make a mistake, but it's doable. Let's go ahead and set this up. This is underneath. This is in the denominator. So it's going to come outside. I think I'll just do it right here. In the box goes this. Check your order. Make sure we have 2, 1, none. So we don't have to add any 0 x squareds or anything like that. It descends in order. So we've got 2x squared. We can just write it in. Power of 2, a power of 1, and then none. No power. Let's start. What times 2x gives me 2x squared? Well, we've already got the 2. We just need another x. X times 2x, because when you multiply, you add the exponents. So x times 2x is 2x squared. X times a minus 1 is a minus x. So you set it up with the first term, but then you do have to multiply. Change the signs. It's a subtraction at this point, just like we did over here. And add those drop out, 6x. bring down the next term, and do the same process all over again. What times 2x gives me a positive 6x? Well, that would be a plus 3. Remember, you always have plus or minus when you go to the next part. 3 times 2x is 6x. 3 times a minus 1 is a minus 3. All right. So we have a remainder. So then we change the signs. Don't forget to do that. And then combine these. So that drops out, always, plus 2. So we have a remainder here. What do you do with the remainders? Well, if you look here, going back, we put 1 over 2. Well, that's what we're going to do here. We're going to put 2 over this. But because it's a positive 2, we write it a little bit different. We go plus 2 over the remainder. So that would be your answer. All right. So, it's a little bit different here. We don't put a plus here, or, if that's a minus, we don't put a minus. But here, if it's a positive, you'll put plus. If that had been a negative 2, we would have wrote a minus there instead. And then you put that over that, just like we do the 1 over the 2. All righty, let's try another one. Last one with long division, I think. And then we're going to look at another method of dividing these. All right, so let's go ahead and we're going to set this up. We've got x plus 1. That goes outside. Now the x cubed and then the 1. So here in this example, we're missing the x squared. We're missing the x to the first. So we're going to have to include those in here as a 0 x squareds, 0 x's. So we start with our highest power. We do not have an x squared. I always use a plus. If you used a minus, it's all right, but why do subtraction if you don't have to? And then we don't have an x. Okay. So we have 3, 2, 1, and then no x plus 1. We have our constant there. All righty. So now that we have it set up, we're going to start the division. You ask yourself, what times x gives you x cubed? Well, that would be x squared. X squared times x is x cubed. X squared times 1 is a plus x squared. 1x squared. Don't forget to change the signs, easy to do. And then that'll drop out. 0 and a negative 1 is a negative 1x squared. Bring down your next term. Now we do the process again, only using this. What times x gives you a negative x squared? Well, we're going to have to do a negative x minus x because we want it to match this in sign as well. So a negative x times a positive x is a negative x squared, adding your exponents. Negative x times a positive 1 is a negative x. Change your signs, add them together. Subtraction is plus a negative. So don't forget to change your signs. Opposites, perfect, that drops out. 0 plus 1 is 1x. Bring down the plus 1. Do the process again. What times x gives you x? Well, that would be plus 1. 1 times x gives you x. 1 times 1 is 1. Change your signs and then add them together. And no remainder, so you don't have this like the plus. Let me move this down. So you're not going to have this right here with your remainder. It's just this. You could check this one. This one wouldn't be too bad. So what we've done is if you take this times this, you get what's inside. So as a quick example, going back to, let's say 8 divided by 2. Okay. 4 times 2 is 8. So 4 times 2 is the 8. So it's a way of checking. If you wanted to use the distributive property, x times all of those, 1 times all of those, and you're multiplying, which we did in chapter, well, this chapter 5.1, 5.2, somewhere in there. You would come up with this right here, x cubed plus 1. All righty, perfect. All right, let's look at another one. Let's see. Oh, let me look. Before we start synthetic division, we had one more idea to look at here. I'm going to move me up here. Okay. Looking at this right here, sometimes we are left with a remainder. Okay. Now, did I copy that one down? Yeah, because I'm looking to see. Other one had a remainder. I don't think on that second one, I don't think I made a mistake, but all right. Okay, so here we write out the answer the same way we do when using long division of real numbers. So this is just kind of a different one with the remainder. But look at this right here. We've got an x squared and we have a 1. So I recommend that just to stay in the habit, well, I'm going to put it up a little bit. A squared plus 0a minus 1. I would go ahead and add that 0a. You might be able to, with some of these, to get away with not doing that, but I just have the descending order, and that way things should really line up well when you go through this. I want to check something really quick. Okay. Now inside, be careful of this, because here they don't have this in the right order, but you have to put it in the right order. So we have a cubed plus 9a squared. I'm just putting it in order. There's no a to the first, so I have to add that in, and then you have your constant. So I included it here. The missing term is a 0a, and then I also included it here, right there. So yeah, and it makes things just line up when you start to bring things down and subtract them. And then you just go through the process. Now, looking at this, we'll go ahead. Let's go ahead and practice this one more time, and then we'll do the synthetic division. Yeah, I got time. All right, so we have a, because a times a squared gives you a cubed. So we have a cubed. A times a squared is a cubed. A times 0 is 0, a squared, because you add the exponents. A times a minus 1 is a minus a. Change our signs. Add them together. That dropped out. I have 9a squared, because 9 minus 0 is 9. And then 0 plus 1 is just 1a. When you add those, a plus 0a is a. Then you bring down the next term. And you do the process again. What times a squared, what could I multiply the a squared by to get 9a squareds? Well, that would be a plus 9. 9 times a squared is 9a squared. 9 times 0 is 0a, because 9 times 0 is 0. 9 times a minus 1 is a minus 9. Change the signs and add them together. It's the subtraction. those drop out. Looks like we're going to have an A. Yep. Plus 4. So that would be the remainder. There's nothing else to bring down. We're done. And what times a squared gives you an A? Can't do that. So you can't go from a more to a less exponent. So how do we write this? We would write it as a plus 9 plus a plus 4 over the denominator. When you do the denominator, you don't have to include that 0. Okay, you can just write the a squared minus 1. There you go. So you just put plus this over that. All righty. So that's all for long division. If it's still confusing, let me know and I can help you out. The next one we're going to do is a little bit simpler. It doesn't look as complicated, but it has its limits, and that's synthetic division. The nice thing is, for those of you that do go into 1400, you'll use synthetic division quite a bit more than you will the long division. It still will come up, but not as much. So we're going to look at synthetic division, and it was actually going to, for when you can use synthetic division, it will simplify things. And what are its limits? Well, in order to be able to use this, we have to have the form x minus a, or you can even use x plus a. So you can use synthetic division when you're dividing by, this is the bottom, this is our denominator, something like x plus 3, x minus 1, x minus 4, x plus 5. All of these could be used with synthetic division if these are the denominators and you've got something up here. When can you not use synthetic division? If you have 3x minus 4. All right, that you're not allowed to use. You can't have a number in front of the x. There has to be a 1, a 1, a 1, a 1. And you can't use an x squared either. So we could not use it on the last one with that x squared as a divisor. All righty, so let's hope when you're given a division problem that it looks like this, because synthetic division will simplify this process up here. So let's go through some examples and the steps. So here, set up the problem. First, set the divisor equal to 0 to find the number to put in the division box. This will all make sense when we go through an example. Next, make sure the numerator is written in descending order. So in synthetic division, if we're missing a term like we were in the long division, you have to add your 0x squareds, your 0x's. All right, so that'll be an important one. Let's just go ahead and look at this step 1 as an example. You take this right here and set it equal to 0. Add 2. You'll be able to do this in your head, I'm sure. X equals 2. Now, what we're going to do is we're going to put this 2 in a little box over here. It looks like that. Yeah. All right, so there's step 1. So you set it equal to 0, and then put it right here. It's one step. This will always just be a one-step solve. Now, we're going to list the coefficients without the variables. So we've got the coefficient of 1, 6, -1, -30. We are not missing any exponents, so we don't have to put a 0 anywhere. So we have 1, a little space, 6, a little space, -1, -30. So I listed that. All righty. So you list the coefficients without the variables, even though this is the x cubed, this is the x squared, this is the x, and there's our constant. We don't put these in the problem. We have to keep them in mind for the answer, but we don't put them in the problem. Give yourself a little bit of room because we're going to write some numbers underneath these and draw a line. So now to start the problem, okay, let me look. Once the problem is set up correctly, bring the leading coefficient, the first term, straight down. So all we've done is step one. We found out what to put in the box, and then we listed the coefficients. Now, step two, bring this straight down without anything. Just bring that coefficient straight down. My line is not straight, but I think I can deal with it. Now you bring that straight down. Now you take 2 times 1. So here, multiply the number in the division box with the number you brought down and put the result in the next column. So 2 times 1 is 2. And then you add those. There's no changing of signs here, not in this whole synthetic division like there was above with the long division. So you bring this down and then you start. You multiply, then you add. Then you multiply, and then you add. Then you multiply, and then you add. And you're pretty much done. So it seems to be a little bit simpler once you get used to it. So what's the answer? These are the new coefficients in front of our quotient, and we have a 1. I'll put the 1, and you always drop it by 1 power. So that'll be the x squared plus 8x plus 15. And there was no remainder. So these are the coefficients. The x's, you start with an x cubed, you go x squared, and then just go down. What does this mean? That if we had used long division, x cubed plus 6x squared minus x. If we would have gone through the process, we would have had x squared plus 8x plus 15. Okay. All right, so it's another method. It's quick. You can only use it if you have a 1x and then a number here, minus or plus. So it does have its limits, but here's your quotient. So let's go through a bunch of examples here so that you'll understand how to do this, because it'll be used pretty extensively if you take 1400. All righty, first step, set this equal to 0. So x is a -3 if you subtract 3. So that's the number in the box. Excuse me. Now we're going to list the coefficients in order, and if I'm missing one, if I'm missing a variable, I put a 0 in that spot. So here we start with a 2, x cubed, minus 7. We're missing the x to the first, then minus 5. So we were missing the 0x. So I put that in as a 0. All righty. So pretty much the hard part's over. It's just getting this set up. Draw a line here. Leave yourself some room to write numbers. Bring this down. And you start your process. You multiply. And then you add. Then you multiply, positive 39, and then you add. Then you multiply, let's see, 9, 117. Let me check that. 39 plus 3, yeah, 117. Negative 117. Let's put it in the wrong spot. Okay. So again, you bring down the first, multiply, add, multiply, okay, and you get positive 39, add, multiply, and now you add. So we come up with negative 122. That's quite the remainder. All righty. So here you can write your answer. We started with an x cubed. That means that's the coefficient for the x squared. minus 13x, and then you just go down. All right, what do you do with the remainder? Well, the remainder, you take, it's a minus 122 over the divisor, x plus 3. You put it over the divisor, the remainder. And the reason I have this subtraction is because that was a negative. And then there's your answer. Okay. Now, this has some significance, but we may talk about that later. I just want you to get this process down before we start talking about some additional things that tells you. All right, let's do another one. Again, our first step. Subtract 4, x is a negative 4 inside our little box. So we put a negative 4, and then we list our coefficients in descending order. So here it should actually be 3x cubed, then 10x squared. I'm just rearranging it. Minus 13x minus 20. So I put these in descending order. It doesn't look like I'm missing anything, so I will not have a 0 in a spot, because this one was missing the x to the first, so I had to put a 0 there. All right, so we've got listing our coefficients, 3. We have a little bit of a space, a 10, negative 13, negative 20. All righty, so now to start, second here. This out. We just drop the 3. That's how you start, just drop it down. So again, once you get it set up, that's the hard part, and then this isn't really too bad. Drop it down, multiply. Negative 4 times 3 is a negative 12. So when you multiply them, you put them underneath the next number. Negative 2. When you add them, then you take negative 4 times a negative 2, you get a positive 8. Add them. Then you take a negative 4 times a negative 5, and you get a positive 20. And then you get 0. Now, this first one was an x cubed, again, which means this is an x squared. It's always 1 less x power. So 3x squared minus 2x minus 5. No remainder. So what it means is that this, so I'm gonna rewrite it here real quick using the long division. 3x cubed plus 10x squared minus 20. We would have used the long division on the top, we would have gotten this. Okay. What it means is if I take this times this, I get this right here. All righty. So you've broken it into 2 parts. You've taken this and broken it into 2 parts, just like you can take a 6 and break it into a 2 and a 3. We've done the same thing. All righty, so this is our answer. That's our quotient right there. And this is just a way to check if you wanted to. Let's try another one. First step, a plus 5 equals 0. So a equals a negative 5. So that goes in our box. We have all these negatives. All right. Now we're going to list this next part in order. So it doesn't look like we have any zeros. We have a 1 and an 8 and an 11. Okay. Bring down the first number. And then you multiply negative 5 times 1 is a negative 5. And then you add. Then you multiply. And then you add. So this one also has a remainder. Okay, it wasn't 0. So this was an x squared. That was our first term, or sorry, an a squared. I guess I can use the same variable they did. So that's an a squared, which means this is a 1a to the first. I'll go ahead and put the 1 plus 3, descending order. Then we have a minus 4 over a plus 5. You put it over that divisor. So here it's going to be a plus 3. I'm going to get rid of that 1 in front. It's not that it's wrong, but that's better. Okay, let's try another one. First step, x minus 1 equals 0. So x equals 1. So that 1 goes in the box. Yeah, I'm going to put it right here. So 1 is in the box. Now we're going to list these in descending order. Well, we start with an x to the 5th, and we go to the constant. So we've got x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 1. We have to include all of those down to the constant. So we've got a 1, and I'm going to move it over. Change my mind. So we have a 1, and let's see, we have a 1 in our box. So we have a 1 in the box. So we have a 1, a 0, a 0, a 0, a 0, and a negative 1. Okay. So now it's set up, the hard part. It's set up. I got this number by setting the divisor equal to 0. And then here going down in power till you get to the constant. So I had to add a bunch of zeros here for my missing terms as I go down from the highest power down to no power. And here I draw my line. I bring the first one down. Then I start to multiply, put it here, add. So here 1 times 1 is 1, add. 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 Okay, now what is my answer? Well, this first one was x to the 5th. So this is going to be the coefficient of an x to the 4th. It's always 1 less. So we'll have 1x to the 4th plus 1x cubed plus 1x squared plus 1x plus 1. And there's your answer. Okay. Well, that pretty much does it for this section on division with either with a monomial or long division or a synthetic division. I just want to, again, let you know that synthetic division to me is a little bit simpler than the long division. Once you learn it, I think you'll like it, but it does have its limits. So it will not work if that divisor has a number in front of the x, or it's like x squared, then it won't work either. It can only work if it has the form x minus a or x plus a. Okay, where a is a number. That's it. And then you can use this process. To me, there's a lot less places to make a mistake than if you use the long division. Okay, hey, let me know if you have any questions, and just contact me. All right, bye-bye.